All right, let's jump right in. Today, we're diving into an explainer that is literally about the end of everything. We're going on a mind-bending journey into the ultimate fate of our universe, specifically a time known as the Degenerate Era. Drawing directly from the fascinating sci-fi narrative, The Last Light of the Degenerate Era, we're going to explore the staggering physics surrounding the very last human alive and how the uncompromising, brutal laws of thermodynamics dictate the final chapters of existence itself. So let's set the scene for this chilling reality. We are entering a scenario where the universe as we know it is completely, utterly unrecognizable. The grand, bright stars of the early universe, long gone. Even the super conservative red dwarfs have completely cooled down into black dwarfs, which are essentially just these massive, freezing, crystallized spheres of helium and carbon. Space is a perfect vacuum, swept totally clean by eons of gravity. And, as this quote hits right on the head, the second law of thermodynamics is actively hunting down the very last embers of existence. Heat death is the ultimate predator. Think about it. To do any kind of work, whether that's keeping a human heart beating or just powering up a screen, you need a thermodynamic gradient. You need a difference in temperature. And in this era, that difference is totally vanishing. To really wrap our heads around the immense scale of what we're dealing with, we have to look across deep time. Right now, you and I live in the Stelliferous era, the golden age of starbirth. But our story takes place roughly 100 trillion years after the Big Bang. By this point, the expansion of space driven by dark energy has pulled every other galaxy cluster way beyond our cosmic event horizon. The distant galaxies have literally slipped away into nothingness. The local cosmic microwave background has redshifted to an unimaginably cold 10 to the power of negative 29 Kelvin. That is virtually indistinguishable from the absolute zero of the quantum vacuum itself. Now, you're probably wondering, what happened to humanity in all this time? Well, we basically took two divergent paths. The vast majority of people uploaded their consciousnesses into what are called computronium spheres. These are massive, planet-sized computers orbiting fading stars. But here's the ultimate irony. Even a digital heaven can't escape thermodynamics. Computers require heat sinks to discard waste energy. And as the universe's background temperature dropped to near absolute zero, their radiators failed. Over trillions of years, they just degraded from micrometeorite impacts and data corruption. Meanwhile, a super stubborn faction of humanity believed biological forms were the true anchor of who we are. They survived by using this extreme cycle of cryogenic stasis, literally sleeping for 50,000 years at a time. Which brings us to the ultimate survival question. When you are the very last biological human in existence, a guy named Corin living on a miles-wide ring station called the Hearth with an AI named Mnem, how do you cheat a universe with absolutely zero thermodynamic gradients? I mean, if there are no stars left to provide heat, how are the lights still on inside this station? How do you survive when the universe itself has run out of heat? The answer is actually brilliant. You use the universe's most efficient engine by orbiting a gently rotating giant, a Kerr black hole. In our source material, this specific black hole is named Sovereign, and it weighs in at roughly 80 million solar masses. Now, I know what you're thinking. It's a black hole. Wouldn't that just completely shred a person? Actually, no. Because Sovereign is so supermassive, its event horizon is incredibly vast, meaning the gravitational pull across a human body is actually totally negligible. It's a gentle giant. And crucially, it is the absolute last viable source of usable energy within their cosmic horizon. So a Kerr black hole, like Sovereign, is defined by two distinct boundaries. You've got the outer boundary, which is known as the static limit. And then you have the inner boundary, the event horizon, which is that famous point of absolutely no return, where nothing can ever escape. But the really fascinating part? It's the region trapped right between those two boundaries. It's called the ergosphere. And the mind-bending physics of what happens inside this ergosphere is exactly what is keeping our final human alive. What makes the ergosphere so incredible is a concept called frame dragging, also known as the lens-Thering effect. Because Sovereign is spinning, it literally drags the very fabric of space-time around with it. It's kind of like a spoon stirring a jar of really thick honey. Inside that ergosphere, space is being dragged so violently that absolutely nothing can remain stationary relative to an outside observer. Even if you fired your engines and tried to fly in the exact opposite direction at the speed of light, the space itself is moving faster. It just sweeps you right along with the black hole's rotation. To survive in this absolute darkness, Corin and Mnem pull off a literal cosmic heist using something called the Penrose process. Here's how it works. First, you launch an object, let's say a 10-gram metal pellet, into the ergosphere on a super specific trajectory. Second, once you're inside that crazy frame-dragging zone, you split that mass in two. Third, you throw one piece backward against the black hole's spin. Because of the insane physics here, this piece actually acquires a negative energy state as it falls past the event horizon. And finally, step 4. The other piece gets flung outward, and it escapes with more kinetic energy than it started with. You are literally stealing rotational energy directly from the black hole. The theoretical limit for this conversion is 29% efficiency. Just to put that into perspective, that vastly outperforms nuclear fusion. It's incredible. But, the Penrose process isn't free. You have to supply the mass to drop into the black hole to make it work. And here is the devastating reality of Corin's situation. 412.8. That is the exact number of kilograms of disposable baryonic matter they have left. Period. The storage silos are totally empty. They've already ground down and consumed the last of the iron silicate asteroids. So this final chunk of mass, it's made up entirely of scrapped drone hulls and decommissioned historical archives. This stark comparison right from the text really highlights the sheer bleakness of their ledger. 412 kilograms is literally less than the mass of a grand piano. If they just keep feeding the scrap metal into the Penrose engine at their absolute lowest metabolic rate, just keeping the station heaters barely on at 7 degrees Celsius and the cryogenic pod running, it's only going to sustain Corin for another 8,412 years. And look, in the grand cosmic scale of a universe that's 100 trillion years old, 80 centuries is barely a rounding error. It's just slightly delaying the inevitable moment when the temperature drops to the background of the cosmos and he freezes. Faced with this cold, absolute mathematical certainty, Corin refuses to just fade away with a whimper in some freezing box. Instead of stretching out his sleep for another 80 centuries, he makes this beautifully defiant choice. He tells the AI, Mnem, that they should break down absolutely everything they have left to write one final sentence into the dying cosmos. They bypass all the safety protocols. They melt down titanium bulkheads, dead batteries, vacant living quarters. They grind the whole station down into highly dense 10-gram spheres to fuel one massive final project. They reconfigure the station's massive communication dish into a high-intensity directional laser, literally harvesting pure monocrystalline diamond from their own windows to use as focusing mirrors. And they make a highly specific choice for this laser. They tune it to a wavelength of exactly 520 nanometers. Why that number? Because it's green. It's the peak emission wavelength of their long-dead home star, our sun. It represents the color of chlorophyll, of pine forests, of oceans under a bright midday sun. It is the definitive, undeniable optical signature of life. And this isn't just a beam of light either. It's literally a message in a bottle thrown into a shoreless, empty ocean. Mnem encodes this brilliant emerald laser with an unbelievable data stream, containing the absolute entirety of human knowledge and history. We're talking the sequence of the human genome, the fundamental equations of quantum mechanics, Beethoven's symphonies, digital scans of ancient art, and the names of every single recorded human being. Every word we ever spoke translated into a massive stream of photons. Firing the Penrose engine at maximum capacity, dropping those 10-gram pellets in this rapid rhythmic beat, they violently and beautifully burn up their physical heritage. The engine converts an astonishing 99.8% of their remaining mass into a massive surge of electrical current. A beam of intense, emerald green light stabs out into the absolute darkness of the cosmos, traveling outward at the speed of light, roughly 299,792 kilometers per second. For 10 minutes, this pure, coherent energy cuts through the tired, dead universe, expanding as a shell of green photons, carrying the memory of Earth deep into the future, even though the expansion of space ensures it will probably never, ever be seen. But of course, physics demands a final toll. Having completely exhausted their mass and losing their orbital velocity to the laser's massive recoil, the station's orbit decays. The pod inevitably falls toward Sovereign. And as they approach the event horizon, the staggering physics of relativity completely distort their visual reality. Through a phenomenon called gravitational lensing, the faint, ultra-redshifted light from the background universe is violently bent around the black hole, forming this highly distorted ring known as an Einstein ring. Because of relativistic aberration, the entire universe behind them literally squeezes into a shrinking, brilliant circle of light. But the most awe-inspiring effect is what actually happens to time itself. Due to extreme gravitational time dilation at the edge of the event horizon, time for Corin slows down to an absolute crawl compared to the outside universe. Because of this, he effectively watches the spectacular, accelerated death of the remaining cosmos play out right in front of his eyes, like a movie in fast forward. He sees distant black dwarfs collide in brief, cold flashes. He watches the last supermassive black holes slowly evaporate over incomprehensible eons via Hawking radiation. But to him, those unimaginably long lifespans are compressed into spectacular, microscopic flashes. And then, they peacefully cross the event horizon. There's no violent ripping, just a soft, weightless embrace as the tidal forces remain super gentle. But mathematically, the very laws of physics warp to an almost unimaginable degree. Inside the event horizon, the radial coordinate, which measures physical distance, and time itself literally swap places. What this actually means is that the singularity at the center of the black hole is no longer just a physical place in space. It becomes an inevitable moment in your future. Trying to fire thrusters to escape it would only bring you to the singularity faster, just like trying to run away from tomorrow only brings tomorrow sooner. It's beautifully tragic. As the pod loses its final reserves of power and drifts in the absolute darkness of the interior toward that singularity, Corin closes his eyes and just smiles. He was the very last human in the universe, and he actively chose to leave the lights on. It's such a poignant ending that perfectly captures the intersection of cold thermodynamics, mind-bending relativity, and pure human defiance. And it leaves us with a really profound final thought to ponder about our own legacy in this vast, crazy cosmos. If you were the last observer, what light would you leave in the dark?
Please like and subscribe.